Okay, class. Today kita continue. Kita proceed to our still topic on failure theories based on static loading. Okay, in your previous class, I already explained to you about the failure theories based on static loading. We have three theories, which is maximum normal stress theories, maximum shear stress theories, and distortion energy theory. Okay, maximum normal stress is good for brittle. And maximum normal stress is good for brittle where safety factor equal to kalau it's good for brittle safety factor. I mean maximum normal stress theory good for brittle, which is your safety factor is good for brittle. Hold on, jap. Okay, MNST already explained. Just highlight what I explained to you in the previous class. Maximum normal stress theory, where our safety factor is our, actually it's for brittle, it's for brittle. Kalau if you want to do for ductile also can, but it's not accurate. Good for brittle. Normal stress rate is SU, pasal brittle the limit strength is ultimate strength. You can get any brittle material if you look on your table properties at the end appendix in your textbook. Brittle material like cast iron, they have SU value, ultimate strength, not SY. Brittle is SU. SU over your sigma max. Sigma max ni mean your principal stress. Either sigma 1, you calculate sigma 2, which one is the most biggest one? So you put into your denominator, there's your safety factor. But you can go also for ductile material, even MNST also can go for ductile, but you use SY instead of your SU over your sigma max. Sigma max, I mean, you calculate sigma 1 or sigma 2, and which one is the biggest one, because sigma 1 is sigma 2 always compression, right? Negative. Even negative, sometimes negative is bigger than positive. Sigma 2 will be the max. Normally the case sigma 1 is bigger than in positive side. So that's why you can go also for ductile if you want. For ductile, it's okay. Tapi not that accurate. That's why over sigma max. This one only for, actually is go for brittle MNST. What? For maximum shear stress theory, your safety factor is you punya SY. Ini untuk ductile. Okay, ductile. Only untuk ductile. Ini good. Also accurate. Quite accurate. SY over your dual tau maximum. Yield strength over safety factor. I'm talking about safety factor is yield strength over 2 tau max. This one for good for ductile to predict failure by using calculate the safety factor. Tau max is, you know lah, tau max. You can find sigma 1, sigma 2. For this case, you just simply calculate your tau max. What is tau max? Formula there is tau max is sigma x minus sigma y over 2. Plus, correct me if I'm wrong, tau x, y squared. Pernah mistaken. Betul lah kan? Ini question of tau max. And put it there. That's a tau max. Because in your Morse circle, when you plot you punya x, kata this. Sorry guys, saya punya line macam ni. Okay. You plot Morse circle, what is your tau max? You plot Morse circle, this is your point x, point y. You got sigma 1, you got sigma 2. So in the radius. So this is the radius. This is tau max. You can use by graph or you can simply calculate. Correct me, the equation is right. Sigma x minus 1 plus tau. Yeah, I think this is the equation, right? Okay, tau sy. The radius of your Morse circle, this is your tau maximum. The tau maximum that you calculate, you put into the denominator 2 times tau max. Sy over that one is your safety factor. You can go for maximum shear stress theory. But for DET, the safety factor is your SY over your sigma equivalent. Equivalent stress, equivalent to change the shape but not the size. If we've got distortion energies, sigma equivalent. Sigma equivalent apa equation dia? Sigma 1 square. Macam mana sigma 1 square? Plus, saya kena recall dia. Kalau you punya sigma equivalent, kalau shortcut dia sigma x square root of sigma x square plus 3 tau xy square. Kalau if you happen to have biaxial stress, ada yang sigma 1 apa? Yes, you can use biaxial. Kalau you have biaxial pun boleh direct straight away forward equal to sigma 1 square plus sigma 2 square minus sigma 1 sigma 2. Yeah, this one. Square root of it pun boleh. Atau sometimes shortcut you don't have to calculate sigma 1, just direct by your by axis stress rate atau axis pun boleh. I mean sometimes most of the case lah, for example our shaft, right, on our element, boleh nampak, boleh dengar ke sekarang? Kalau kerana dalam you do element analysis in your element tu, sometimes for the shaft or any case, sometimes you only have sigma x like this, and you have tau xy. I already mentioned to class like that. Okay, tau xy. So you don't have to calculate sigma 1, you just use simply this first equation, sigma x square plus the output, you can get the sequence. So your safety factor is sy or your sigma. This would be your safety factor. Okay, itu three theories. Tapi DET, DET is the most accurate for ductile material. In most of the case, you will do DET. We are still on static failure, not fatigue. Fatigue different question. Ini static failure. Tapi most of the case, your project, you have a bracket, a component that sustain stationary load, not load that is changing through times. You don't have variable loading, not fluctuating. I mean the load remain constant through time, so it means that you straight away use this equation for ductile material. Okay, we go for sample problem. We go for sample problem. Can you look on your e-learning? In your e-learning, please look at your e-learning. Ada boleh nampak e-learning? Plus. Okay, yang kita go for test 1. Ini test 1 tahun previous year, semester 2019 to 2020, test 1 question 1, static loading, relative risk. Question 1 on your test 1. Okay, if you look, this one, okay, I share you, share you. Boleh nampak tak? Okay, this one. Plus. Okay, ini soalan 2 tahun lepas. Okay. Previous test, semester 2019-20. Okay, this is a question none of the exam. Boleh nampak this diagram. Okay, boleh. Ini nampak soalan ni, jangan you feel panic pula. Kalau ini exam, it's straightforward je. Pasal the diagram tu nampak macam quite complicated. Actually, it's simple aja. Okay, we have, let's say you are as engineer working of this company, your company fabricate tripod, what you call it, support for monitor screen, macam desktop monitor screen. You buy monitor screen and you need to, right? Okay, soalan ni, they give you, let's say a local swivel arm manufacturer, swivel arm to support the monitor screen. Okay, has to make decision. So you working in this company, your company manufacture this thing, swivel arm to support monitor screen. And dia ada kind of arm, dia ada arm, dia boleh swing je, they can swing je, and also they have pivot, can swing je. Pivot je and pivot, I mean can go for swing for in Z rotation and also Z rotation. We don't swing for X and Y rotation, only on Z rotation, on Z axis and on Z axis. So you can swing like that. But it can swing, it can swing to X axis also. You can see there is a tightener ni, ini ada like this lah. If you zoom in, dia boleh swing in this direction also lah. Okay, tapi this orientation is like this. Because the monitor screen is so heavy, okay, the monitor screen is heavy and the weight of the monitor screen is 9 kg. So you convert into Newton times gravity 9.81. Okay, the force is 9 kg times 9.81. There is a force vertical. Okay, the centroid of the CG of this is here lah, is located here, of the monitor here. So kita disregard, kita ignorekan the weight of this all the arm, the member. We talking about the orientation. Now the orientation already 220 is like this, and we look from the left view, 220 is like this direction. This angle 90 degree lah. So the critical case, if you have this kind of swivel arm ni, we don't have to analyze all this member. This member is not, bukan kita ada soalan, the question asks you to analyze at the tube, because the tube is critical. Because kalau you, as logically, the most yang carry the bending load and also we have bending load in both, either bending load in x-axis, moment on x-axis, also bending load, if you look from the left view, we have bending load on the y-axis, moment on y-axis. So we have both, because since the A is at the bottom, at this section A is at the throat, at the bottom, no? To at the base, to at A, to that one is the most critical, because there is a lot of, we have member, this means rectangular beam, this could be double rectangular beam. We don't, that one is not under our consideration. We focus on here because the question asks you, because okay, the question, find orientation at point. I mean, this point, this swivel arm, they have component member and it's joined to this kind, like we have a collar here, but this one we have a tube. Okay, the collar we have a tube. Tube. The collar ni they have a kind of the steps ini, the collar ni they will swing at this tube. Boleh dengar saya? Boleh dengar kelas Hello kelas. Okay, sekarang ni kita tengok the tube A tu, only A, you focus on A only. A tu yang critical because they carry the highest bending moment in terms of X, also Y. Moment on X ni is 9 kg times 9.81, that force time the distance 320. Moment on Y, 9 kg times the distance 220. So you have to make the free body diagram, tengok macam mana reaction. What is the reaction? Find all reaction at point A. Okay, find all reaction at point A. Kalau, okay, if you look on my live video, look on my live video. So kita answer the question 1 first. Kita answer the question 1. Boleh nampak saya punya video kelas. Okay, so we have a monitor like this. Okay, we have a monitor macam ni. Okay, there's a load. Kita tahu center ni is berapa? 9 kg. Force kali 9.81. So, berapa? Apa value dia? 88.29. 88.29 Newton. Okay, kita ada arm like this, kita ada arm like that, and kita ada like this, and this one. Kita this member, they're connected like this, different member, different, they are joined this one, but it will swing here, like this one, it will swing Z like this one will swing Z like that. Okay, in Z axis. So yang ni, the bottom tu, we have a tube, tube. Okay, cross section of tube is given in the question. Nampak tak ada figure ni? 25. So the cross section of tube is a tube. It's not a solid shaft. It's a tube, hollow cylinder. 21 is inside and the outside is 25 diameter. Okay, so this is the tube at section A ni. Section A, this section, this section at the base tu. Itu critical lah. Critical. Okay, we know that the distance here, from here to here, if you look, the distance given is 320. Can you see that? 320. Okay, since they said that this one is Y, this is X, and this one is Z. Okay, 320 is here. So it means if you look from the right view, of this ni, and you will see the loading. Ini you punya monitor. Ini you punya load is 88.29. Boleh dengar saya? Okay. And ini you punya, I just make it short. You punya arm like this. Arm like this. And at the tube ni, ni you punya tube A tu. At A tu dia pada on tabletop. Section AA. And the distance, apa distance ni? Is 320. This one, it will cause apa reaction kat this one. Sekarang ni kita find all the reaction at A. All the reaction at A. Ini kat A lah. A section yang bawah ni. So, ini will produce apa? What is reaction causing at A? The tube. Okay, one is bending because of the moment kan. Another one apa? Of this vertical load. Apa reaction ni? Yeah, axial load. Okay, kalau the way you put your free body diagram, you can do lah. This is my tube A, right? Tube A. So reaction is like this lah. The same as 88.29, betul kan? Plus, since the bending is like this, my counterclockwise is like that lah. Counterclockwise. Tetapi tak apa, sometimes it's okay kalau you put the free body diagram like this. It's okay kalau if I'm taking at the end A, the reaction should be react. This one should be 88.29 because this downward reaction is ni, and this one moment is clockwise, and this one is counterclockwise. You can do that also. Tetapi sometimes let's wait kita perceive this thing like this. Okay, at A element, no? What happened at A? At A tu dia ada moment kan, moment is force time distance. This one 88.29 times 320. Okay, so you got the value of berapa tu moment 2.825 2.825 times 2.825 times 10 to the power of 4 Newton millimeter. Correct? Atau ni 28252.8 Newton millimeter. Okay. Alright, ini moment. Okay, this moment, there is a reaction at A moment, and also kita have reaction upward like this lah. Upward like this. And also we have moment. Okay, this okay. Kalau kita look bottom of A, the counter react is like this lah. Of course, the tube and the counter adding. Reaction is like that moment, where moment at A is 28.252.8 Newton millimeter, and we have 88.29 reaction upward. Kelas, nampak kan? Tu reaction at A, kelas. Okay. Ini moment A, ini moment apa? What this moment? Moment ni moment X or moment what? Moment at A ni. Moment on X ke, moment on Y ke, moment Z? Yeah, you are right. Yeah, moment at X. Moment is moment X Moment AX lah. Saya cakap lah, moment X at A. Macam ni. I just label that moment. Macam mana I label dia? Moment A. Moment X Moment X at A. Okay. If you look from the left view pula. You nampak my right view. Tadi right view. Left view. This. Okay. At tube ini, do we have torsion here or not? We have torsion at that vertical tube A tu. Is there any torsion? If you look on the diagram of the this. Yeah, yes, because yes, you are right. We don't have, the force is vertical because of the weight of the monitor. At the tube here, there is no torsion. Unless, katakan, you have force like this. Apa tak? You have force, this force, not vertical, this in X direction. Of course, we have torsion. And also we have moment in terms of Y. We don't have moment of X. Okay, let's zoom into this question. This question, the force is vertical downward. So we don't produce any torsion at the tube. No torsion at all. Tapi we have two moment. One moment ada line, okay. Yang ini at A sebenarnya macam ni lah. At A tu dia produce moment like this lah. I mean upper portion. You understand? Ini bottom portion, reaction is counter. Ni upward. Upper portion macam ni. At A tu dia ada satu upper portion is a downward and moment X yang one we calculate. Understand tak guys? Because of this 88 times 20. They go like this lah. They go like this. The reverse. I'm taking upper portion of it. This one bottom portion memang the free body must be counter react. We have moment X. Moment X turning is like that. Okay. But the direction of moment, kalau if you look, we go for the direction of moment is that direction vector lah. Vector is like that. Pasal it's go turning. Upper portion. I'm talking about upper portion. Okay. And the force is downward. Okay. It goes like that is the direction of the X. Alright. Okay. But when we look, if you look from the left view, what we see? We will see, macam ni lah, we will see that this is a monitor screen. Okay, the monitor screen, and this is a force 88.29 Newton. Okay, and then kita punya arm is like this kan. Kita punya arm is like this kan. The arm is like, so this is the tube. So this is the tube. So we have a distance here. Kan kita ada distance here. Kita ada distance is 220. You can see my sketching. Boleh nampak guys? Clear Tak nampak 220. Okay, if you look from the left view, we have 88.29 downward times, there is a distance 220, nampak tak? Ni section A. Ni looking from the left view. Okay, so that left view, okay. Supposed to be, you cakap saya, kalau this is my free body diagram, okay, reaction at A tu should be upward like this, sepatutnya to be, you already do that on the XY plane, I just do it again here, 88.29, but the reaction of, kalau counter react lah, this upward, this one produce counterclockwise, and this one supposed to be clockwise lah, this one moment at Y or X? Moment Y kan? Moment Y at A, betul tak kan? Plus, this moment Y, axis Y. Clear or not? I draw again, takut you tak faham lagi okay. Okay, sekarang ni reaction dekat tube A ni, kalau ikut logik, bottom of A is supposed to be right, counter react lah, we are 88.29. This one don't have to be, this one already done, it's same thing lah, I represent here, it's the same. Don't add this one double, no lah, I mean reaction 88.29, and but since from left view, it produce counterclockwise, but counter react there should be clockwise lah, this one moment at Y, at A, moment AY. And moment AY ni is, moment AY berapa value dia? Moment AY, moment A at Y ni adalah 88.29 times 220 lah. 220, so the value is okay, 88.29 times 220 is 19,423.8 Newton millimeter. So ini adalah moment Y. So moment Y. So ini kita ambil bottom portion of A. If you look upper portion of A, dia ikut logic lah. Kalau if I look, okay, if I this part, kalau because this one produce counterclockwise, I'm talking about to make it easier lah, to make it easier. Tadi MS go turning this direction, but this one it goes for this direction. Because this one is at the bottom, is supposed to be ni upward ini. Tapi this one kita ambil upper portion of it. I hope you guys not confused. So we go to ikut logic lah. This one turning like this, turning like this. Your moment X at A ni. This moment Y, sorry. That one tadi moment X. This one is moment Y at A, turning like this, ikut direction ni. Upper portion of A. Hope you understand what I'm talking about. MY at A ni, this direction. MX, this direction, because of this one turning like this. But from you look from left view, you produce MY 88.29 times the distance 220 lah. From here to here is 220, right? From here to here is 220. Okay, 220, so it produce MY. No, because I'm talking, you are right, it's supposed to be like this. Okay, hold on. Okay, you are right. Kalau counter react, if counter react, yeah, of course, this one vertical, upward lah. This one counter, because this one yang dia produce counterclockwise kan, this one supposed to be clockwise. Yeah, you are right. But I'm talking upper portion. Yeah, upper portion. This is bottom portion of bottom portion. But yeah, direction should be like that. I'm talking much easier for you to. Upper portion is like this lah. This one I'm talking about. Upper portion like that. Yeah, yes, you are right. You are right. But for, yeah, the way how you perceive it. Yeah, the way how you perceive it. Tapi kalau cakap free program, tetapi be careful. Free program up until betul you must make like this. Is always reverse lah. Counter react. Because nanti kita ada element here lah guys. I'm talking about the upper portion of it. Upper portion to make your base tension is turning like this lah. Keep turning at A like that. Okay. So kalau turning off, okay, if you turning is like this is go for you punya this direction right? You punya moment is this direction vector dia. Kan? The one tadi turning like this is go direction. This one go this direction. Okay, go this direction. So it means kalau saya zoom in, okay, do not confuse. I'm talking about upper portion. I zoom in at my, if I zoom in my tube too, I'm talking about upper portion. So it means I have m this direction vector of my moment. Okay, moment it goes this direction. Do not confuse. Upper portion of cube. Okay, moment. Since this is y, this is x, and up is z. So ini adalah moment A at x. Okay, and here is direction like this. Ini upper portion of A, do not confuse. This is moment A, Y. Okay. Okay, while moment A, X tadi kita have tadi lah, moment A, X tadi adalah we have 28,252.8. Moment A, Y is 19423.8. Okay. And also, tapi I'm talking, do not confuse again. And also kita have downward force, betul lah kan? Class, understand that I'm talking about? Kalau free body diagram bottom, sebenarnya free body diagram supposed to be bottom portion, used to be reverse. Everything is reverse. Tapi I'm talking more to be easy to understand. 88.29. That is reaction at A lah. We consider upper portion of A. Pun boleh. So itu yang part 1, find all reaction at point. You can make your free body diagram. Radius or phone, you can make your free body diagram. Kalau you make your free body diagram bottom portion, sebenarnya kalau ikut more supposed to be, kita cakap yang cara yang betul lah, it is supposed to be like this lah, bottom portion. Bottom portion. This one 88.29, and this is force, the force, and we have like this. Ini go turn, ini supposed to be like this lah. Masa tu pun boleh, M-A-X go like this, and so it's supposed to be macam ni. Ini counter react like that. Bottom portion of it like that, and this one go to like this, counter react, and AY, MAY like that. Okay, MAY, this MAX, MAY, and dia punya turning is like this. This one supposed to be macam tu. Dia reverse. Kalau bottom portion, upper portion itu. So the way, wonder how easy for you to perceive. Kalau macam saya easy to perceive, I do it like this lah. Because I want to study element tu berapa, what is the principal stress. Okay, the part 1 tu kita, you can do it like this, also can do. You cakap this is the way, maybe you put some explanation upper portion of it. Boleh, your lecturer will mark, okay lah, acceptable lah, full point lah. 10 marks on this, ataupun bottom portion supposed to be like this lah. Bottom sebenarnya like this guys, supposed like this. Sometimes the way you perceive it. Clear tak kelas? Hello kelas? Yang lain dengar ke? Clear itu jangan confuse on that lah confuse that. Itu part A find oration, that's it lah. You value tu kena bagi, value kena bagi Okay, tapi sebenarnya you buat macam ni lagi more logically, theoretically like this lah. Tapi the way how you perceive it pun boleh. Besok ini upper portion, kita bottom portion, ini bottom portion. I'm talking about portion. Okay, sekarang ni part 2, find stresses at A. Okay, what is the stresses at A? Okay, let's say kita consider upper portion. I don't want to make easy upper portion. This section A kan guys, section A what happened here? What stress happened here? We have all the volume moment. Yes. Yes. What is the total moment? Remember, you have you see the vector. Okay, I'm talking about upper portion. Boleh upper portion of it, not bottom portion. Can you see the total moment here? Okay, boleh dengar. Okay, if you look at bottom ni, okay, part 1 already we done lah. We this idea, this or this one. Okay. Okay, part 2, find all stresses acting at A. Okay, this for, let's say kita ambil upper portion much easy for us to understand. Okay, our total moment at A is here, betul tak? This vector, class. Because we have Y, MAX like that. I'm talking upper portion, do not confuse. Upper portion, I mean my force go downward lah, upper portion of it like that. So this is total MA. So you have to get the total MA lah. Total MA. So once your total MA is like, so it means this vector is like upper portion again, upper portion. So you punya rotation is because this direction, rotation is like this lah. So you punya rotation macam mana nak buat? Macam tu lah. Okay? They go like that, they go like that. This is a vector. So total MA ni you kena calculate lah. Where is your MAX square plus your MAY square. So you will get the value is 28,252.8 square plus 1942.3.8 square. So you got the value is square plus 28 242.8 square. So you get, oh, hold on, 28.2 square plus 194 square root. So the value is, total moment is 34285.63. Let me check. Okay, the value is, yes, 34285.63 Newton millimeter, total moment at A. Clear? Pasal kita need to find the stress. Okay, kita need to find the stress. So it means at A ni, I zoom the A ni, portion of A ni, this section A. So kita punya, okay, tadi yang we have MAX and we have MAY kan? MAX, MAY, so our value of here, total vector at A ni. Pasal vector is like this. MA ni is 34285.63 Newton millimeter, okay? Millimeter. And also we have downward forces. Force is 88.29 Newton. So ini our moment is like this. We don't have torsion, right? We don't have torsion. So what is the stress happen at this section? So sekarang ni our neutral axis, since our moment like this, total moment like this, so our neutral is at this theta, right? Theta is inverse tangent moment x or moment y. Kita at this neutral axis at this. So okay, this direction moment, so turning moment is like that. Okay, sometimes you confuse, sir, either which side. Okay, if this is neutral, so our axis is yang perpendicular, this one. Looking at this isometric view session, I understand what I'm talking, class. So it will be, okay, you confused. Either this one tension or this one, it's okay, never mind. Understand that since this is neutral axis, your neutral axis no longer on x, guys, no longer on x or y. Neutral axis because your total moment, literally like this, your total moment become like that. Class, are you with me? Okay. Okay, sometimes you might have question macam yang tu cakap either this one tak apa, it's okay, never mind. Either this one tension, compression, kita go, let's say lah, kita assume it's turning like this, supposed to yang ni tension ni. If this is your upper side, yeah, this one to be tension. Tak apa, kalau you take that one tension is the same. This one tension, so okay. It means at element A ni, okay, element at A ni, this is a quadrant. Element A, okay, element at A ni, at this quadrant, okay, go for tension kan? Tension, kalau tension based of the bending, your sigma bending is like this, betul tak, kelas? Hello, kelas? Yeah. We consider tension side. So this will be your sigma, your sigma bending. Your sigma bending. Let's say lah, it's supposed to be upward, supposed to be Z. Tak apalah, kita kalau consider this is sigma X. Okay, just to don't, I don't want to make you confused. Sigma X, because logically our Z, because we want to calculate the Mohr circle, right? The principal stress. Consider this sigma X. Upward, it's supposed to be sigma Z. Okay, to make you, okay lah, let's be exact, sigma Z. Kalau kita appearskan sigma X kan. Okay. Line okay. We have vertical force downward. Which one is either, okay, sekarang ni we have sigma Z because of the bending, if we go for tension side, but plus that we have sigma Z because of what? What is this force causing at element A? The vertical force. Kan reaction at A, we have vertical. I'm talking upper portion of it, guys, to make you not confused. Downward, right? Downward. Just now, this bending. And also plus we have direct force, kan? Reaction at A, kan, we have downward, kan? Upper portion, we have downward force because of the weight of knee. So we have plus another this one. Okay, sigma Z here. So what? Okay, sigma Z based on bending apa? Based on bending apa? Sigma Z, sigma. Okay, I say this one called bending. I don't want to make you confused. Bending. This is because sigma bending upward. We take the tension side. Sigma bending. Okay, sigma bending. Sigma bending okay. Let's say kita ignorekan dulu axial stress. We have also axial stress because of that force downward. Okay, sigma bending, what's the formula of sigma bending? Bending is upward. Kita take the say 32. 32 moment pi d cube, do not use that. That one is solid sharp. What is the basic equation? MC over yeah. So we are hollow tube. Hollow tube. Okay, hollow tube. So hollow tube, dia punya diameter luar dia berapa? Diameter luar is 25, right? Okay, outside is diameter 25. Inside is, sorry, outside is, inside is 21. So DO is 25, D inside is 21. Okay, the inside is 21. So equation the MC, what is C? D is your neutral axis, right? C is what? You punya radius of you punya hollow tube lah. So your C is 25 over 2 is 12.5. Betul tak guys? Class, are you with me or not? C is 12.5 because the outside diameter is 25. 12.5 is your radius, is your C. MC over I. So what is the, okay, sigma bending is MC over I. Sigma is total moment at A lah, total moment. Sorry, moment at A tu, yang tadi MAY square, you total moment. C is 12.5. So we have, okay, what is I? I is apa? Moment of inertia, right? I. So, yes, okay. Yeah, okay. I share you the in your textbook tu Hold on jap. Share it. If you open your textbook, you boleh nampak textbook tak? Textbook. Nampak? You can see textbook properties of session. Kalau you tengok dalam ni, you buka your textbook ni, you go yang dia punya list ni. Ni under appendix ni, appendix B, appendix B, this one So for I, nampak tak? What is the hollow circle? What is I? Plus. I tu apa? Hollow circle. Yeah. Yeah, pi over 64. Diameter outside kan? Diameter outside to the power of 4 minus diameter inside to the power of 4. That is your I. So 5 over 64, 25 to the power of 4 minus inside is 21 to the power of 4. So you got your I value is berapa tu? Tolong kira boleh tangan saya je mengira korang. Kira kan? Betul? Milimeter kuasa 4. Pasal I tu milimeter kuasa 4. Okay guys, faham Hello class, are you with me? Boleh dengar? Okay, so you put into, okay, your sigma, so sigma bending tu is, what is moment? Moment A tu tadi berapa? 34 kan? So you put the value 34,285.63 times your C is 12.5 over your I. I is 9628.20. So you got this one. Since this one is millimeter to the power of 4, actually memang they go for Newton millimeter square. Because this one is moment Newton, this one is. So you got everything is sigma B will be, sigma bending is berapa? Sigma bending berapa? 44.512 megapascal. So this will be your sigma bending. Understand tak kelas? So at B ni, pasal kita go for tension side kita go for tension side. It means at B ni, okay, tension side at element at A ni, sigma bending is, kita go for tension side, sigma bending is in Z direction lah, is apa tu, 44.512 megapascal. Same goes here lah, sigma bending okay, but remember, also, at B ni kita kan, we have direct force reaction kan, I'm talking upper portion of it, ini kita go downward force downward. Understand, Clara? Clara, you with me? So it means element at A ni, we have another force downward here. And also at bottom side go for compression. Remember at bottom side reaction is up. I'm talking up proportion. That's why element I mean proportion. Sigma this is what? What sigma is this? From that 88.29 force down, what does it produce to element? What type of stress is that? Direct force. What stress is it on the element A? This one. Sigma apa ni? Upper portion is go compress. Yeah. What type of sigma? Is it axial stress? Is it bending stress? Is it torsional? What sigma is it? Yeah, you are right. Axial stress. Okay, axial stress. So at A ni, we have sigma axial ni. Sigma axial. Okay, bottom side, it goes downward kan, reaction bottom file. Okay, ni sigma axial. I make it upper portion for you to better to understand because kita weight, the weight kita transfer, we have axial stress. So what formula is axial stress? Force over area, right? Betul? Kan? What is the cross-sectional area of your tube? Tengok textbook tadi. You can see the textbook. What is the area of ni? Area is what? Yes. Yeah. Jadi pi over 4, 20, d outside square minus d inside 21 square. Betul, pi over 4. So the area is berapa tu? 104.513 millimeter square. Be careful. You look on the appendix tu, table properties tu. Tube. This is tube. Be careful. It's not only solid shaft. Kalau solid shaft, not tube, kita tahu sigma axial 4F over pi d, because area is pi over 4 d square, jadi 4F over pi d cube. 4F over, kalau solid shaft, just to tell you, area is pi over 4 diameter to the power of 2 kan. Force, jadi 4 apa ni, force over area 4F pi d square, sorry, not pi d cube, 4F pi d square. Okay. That one is solid shaft. That one is force if solid shaft. Tapi kita not using it. Ini we have to use ini F over area. Area is hollow tube. Area is because this is hollow tube. Minus area outside diameter minus inner diameter. So the area is one. We use the equation. Okay. Sigma SL is force. Why is force is 88.29 kan? Kan kita punya direct force, vertical force reaction at A. Okay, I'm talking upper portion, go for compression. So sigma SL is, okay, kita punya F axial is 88.29 over 144.513. So this is Newton millimeter megapascal. So the value is 0.611 megapascal. Little bit smaller, compare bending tu, nampak the bending to cos is greater, 44.512. Yang axial force actually is quite low, 0. Okay, right. Okay, so you punya sigma axial is sigma, boleh nampak sigma axial is 0.611. Okay, so it means sigma axial dia, okay, you punya element at A tu, I go for tension. Kita ada dua case, one tension side, one compression side. For tension side, okay, tension side bending produce upward pasal tension. But from the direct force yang tadi, from axial stress tu, is, ini adalah 0.611. Kan, ini 0.0.1. So element at A ni, 44 point total stress, because nampak both is sigma, right? Total stress is 44.12 minus, because this is go compression. Understand tak, class? Class, are you with me? So total force at A, intention punya case, dia dah deduct kan? Dia dah deduct. It means at A tu, dia become like this, because this one tension is greater, 44, but we have to minus with axial, because axial already compressed it. So it means that at A tu, we have to deduct. So it means 44.512 minus 0.611. So it becomes still tension guys. Still tension because tension is greater than compression. Tak, a little bit lower, 43.901. Ni sigma, total sigma. Total sigma on z-axis at element. Pasal we z-axis lah. Understand tak? 43.01 because kita deduct pasal this one potential, this one compression. So we have to deduct 44.12 deduct 0.0. So we got 43.901. But if we look, okay, I look this diagram. Kalau kita go for compression side, because this is our neutral axis, right? Class, are you watching? Boleh nampak video? Yeah. We go for compression side, kita have both direction downward. So element at A tu, kalau we go for compression side, element at A on the other side. On the other side, it means here. Okay, tadi this one tension, the other side tu, because this is neutral axis, the other side tu, because we have both. One in compression, nampak tak? This one tension, this one the bending tadi cause tension. Compression in both is tension. You understand what I mean? On compression side, it means both is tension, both is compression. So tadi kita have total sigma tadi is, kita already calculate, right? Kita already calculate that sigma bending tadi is 44.512. Yang ni kita go tension pasal dia up, dia go tension lah. Tetapi on the other side of neutral axis, compression mode. So sigma bending ni go for downward. Go for downward. So 44.512 ni downward. Sigma bending ni 44.512. Pasal kita go for compression side. Ni also sigma bending. Plus that we have tadi sigma axial also downward, right? Sigma axial tadi berapa sigma axial? 0.611. So kita add it up. Nampak tak? So element at A ni critical at compression side. So total element sigma at A ni we add it up. Class, okay? Nampak ada problem lain? Okay? Yeah. That's how you have to decide. Yeah, you have to do both case. Yes, you have to do both case. So it means the element, okay, at A ni, this one you have to add it up, both in compression. So we add 44.512 plus 0.611. So we got total is, this one greater, little bit higher than in tension side. Because tension side, we have 43.91 because we deduct, right? Tapi still in tension mode. But compression mode, in compression punya side of your neutral axis compression, we have 45.12. It's much greater compression rather than 45.125 megapascal. Because totally both is in compression. You understand, class? Faham tak? Okay? So that one is, okay, the stress that happened dekat A is like this. We don't have any torsional stress in this case. Kita don't have. Pasal kita combine the bending and the direct axial stress. Axial stress plus bending. Okay, bending kita ada combine MX, MMY tadi. Be careful. So we have total. So this is what happened at A. So like this. So that is answering the part 2. Okay, answering. Okay. If you look on this question, soalan tadi, mana soalan tu? Soalan you boleh nampak kan? Soalan dia part 3, find all principal stress. Part 3. Then you find all principal. How do you find? Okay, if this our element is like this. Okay, the worst case kita compare, we are not taking the tension side. Okay, kalau our worst case is compression mode lah, compression mode. So how do, okay, kalau this is consider this is our Mohr circle lah, easy for you like this. Kalau Mohr circle, let's say kita rotated like this lah. Rotated like this, to make it easy. I rotate it 90 degree to make, okay, compression mode is like this. 45.12. This is total sigma, total sigma happen at A. Total sigma. Bending plus the axial stress, 45. Because easy for you to make Mohr circle like this, okay? That's all. We don't have any torsional, no tau, we don't have any tau. So in this case, ini adalah compression mode lah, compression side, compression punya compression side. Because that one, the highest of 45.12 in compression. So find the principal stress. What is the principal stress? How do you make Mohr circle? Atau you boleh buat macam ni je. Sigma 1 apa? Sigma 1 is sigma x plus sigma y over 2. You don't have to use Mohr circle. Plus sigma x minus sigma y over 2 square plus tau xy square. So, do you have sigma y tak? Because this guy, yang ni I rotated it 90 degree to make you understand. Do you have sigma x? Ada tak? Ada lah. 45.12, right? Okay? 45.12. Do you have sigma y? No, kosong. Tak ada. Sigma x ada. Sigma Y tak ada. Tau SY, what value of SY? Do you have tau SY? No, kosong. So the value you substitute only your 45.12 ialah divide by 2 plus ini square root yang ni. So you got your sigma 1 value is sorry guys. Sigma 1, this is compression side guys, sorry. So compression side you go for negative lah be careful about it. Compression side, kalau you actually you can do more circle Sigma 1 is sigma x, sorry. Sigma x ni is value is negative guys Kalau you put into equation, be careful ni cuai ni sigma x pasal this one negative value or positive value? Negative kan? Kelas. So negative 45.12 over 2 plus square root ini negative kan? Negative pasal dia kompresif, be careful So we got 0 we got 0 over 2 square. So ini negative value, the same value plus this one, we got 0. Understand class? Okay. So plot kita like this, plot kita pasal kita kompresif tau, plot kita sigma kita 0. So this one will be sigma 2 like this because we go more on this is tau versus stress. Sigma 2. Sigma 2 yang kita get the highest value lah pasal kita both on comprehensive. So sigma 2 equation is what? Sigma 2 apa? Sigma x minus sigma plus sigma y over 2 minus this one is minus lah kan? Minus sigma x minus sigma y over 2 square plus tau xy square. So in this case y0 lah. Y0 and sigma x tu be careful lah. Ini negative kan? Ini negative 45.12 over 2 and this one negative. So it means the negative this one tolak kan? So dia become double lah. So this one is negative 45. Pasal negative value because dia compressive kan? Be careful pasal dia compressive. Kalau tension value is positive. 0.12 over 2 square. Okay, so this one kalau you minus tadi minus and plus cancel out 0. So minus double of it lah. So sigma 2 is negative is the same value lah 0.123. Sigma 1 is 0 pasal dia cancel out. Okay, sigma 2, so this one you punya, so this is your principal stress. Understand that class? Principal stress. So sigma 2 is negative 45.123. So tapi principal stress satu lagi ada. Sigma 1 0 lagi. Principal ada 3. Sigma 1, sigma 2 and tau max. Tau max. So what is tau max? Tau max apa? Equation tau max apa? What is equation for tau max? Sigma x minus equation. Sigma x over 2 plus tau xy. Divide by 2 lah kalau ikut logic. I'm talking about equation. Sigma 2 divide by 2. You are right lah. Kalau equation like this kan, kalau sometimes student like this, square root. Ni kan? This equation right kan? Betul Equation dia like this. So sigma y0 and ini logically by this, tapi I'm just kalau like this lah, you macam ni lah, sigma x is negative 45.12 minus 2 square plus ni 0 tak ada. So apa? Ni lah negative 40 pasal square, so 45.12 divide by 2 lah kan? 2 divide by 2. So tau max is the 22.561. Kira logically divide by 2 lah. Kalau you question this lah guys. Be careful kalau compression this value is negative. Why do we don't have tau y? So this is answer the part 3 question. Kenapa enggak? Class, are you with me or not? Alright, good. Okay, sekarang part 3. Apa dia tanya? Tapi sorry, part 4 Okay, part 4 ni. Part 4 ni kadang-kadang try to save the student. Kadang-kadang student miscalculate for the winning. Then you, if the principal stress, ini part 3. Normally exam question ni they try to have friendly, very friendly. Kadang-kadang you miscalculate part 3 or totally part 4, everything will affect, everything will be wrong. So you cakap principal stress is itu. If ni dia dah shortcut for you. If sigma 1 is 2, sigma 2 is 0, dah easy lah. What is the safety factor based on DET? Ni I think you tahulah. Macam mana? Are you looking at the question tak? Dia cakap if sigma 1, ini dah shortcut. Ini actually part 4 ni dia try to friendly lah. Dia tak, sometimes student miscalculate from the beginning. Part 4 everything affected So sometimes it just give you 2 places. At least you get point from part 4. Okay, dah shortcut. You don't care about yang part 3 dia answer tadi. Yang just part 4 focus on what cakap. If sigma 1 principal stress is 62 megapascal and your sigma 2 is 0. Okay, you mean your plot circle macam ni lah. More circle like this. Sigma 1 is 62, sigma 2 is 0, so your marker circle is like this. Okay, it's like that. So find safety factor. Tak payah more circle pun tak apa, you don't need to draw more circle. What is DET? DET equation apa? Find safety factor for DET. Kelas, dengar. Okay, DET safety factor. Find safety factor at point A based on this way. Kalau at point A already give you this one, if the case sigma 1, 2. Tapi in our case, sigma 1 kita not like that kan. Sigma 1 kita 0, sigma 2 is negative 45.123. Understand? Tapi tak apa, for part 4 tak ada kena mana. It's not relevant to just give you short answer. Kalau DET is ni berapa? What is DET? What is safety factor? DET. SY over sigma E. Yeah. Sigma E is what? Sigma 1. Apa? Sigma 1 square. 2 square minus sigma 1, sigma 2. And square root of it. Kan? Okay? So, put the value lah. Okay? Put the value. So, you got, itu je lah. Itu yang answering the part 4. So, the answer is sigma E is 62 megapascal. And safety factor is, okay, safety factor is SY over SE. What is SY? Yield strength is what? Soalan cakap, what is the value of the, what is the material? Okay, line putus. Are you with me, class? Okay, the question, can you see the question? The question is, they give that the tube is made of, the tube at section A tu, the tube is made to AISI 102 hot roll. So we can get our SY value, right? So if you look on the, you can see my textbook, betul textbook. Okay, table properties or appendix material properties. Ini. Okay, you can look. AISI 1020 hot roll. Boleh nampak my textbook, guys? Class 1020 hot roll. What is the SY value? In megapascal to 90. Nampak Class, ni.
Nampak apa?
1020 290. This one. Okay? Apa saya buat ni? Erase. Okay? This one. 102 hot roll. Ni. Jangan ambil KSI ni. Megapascal 290. Do not ambil SU. SU for brittle. Kita datar SY 290. So it's 290 So 290. So yeah, SY is 290. So if you look my live video, you just divide lah. So safety factor is your 290 megapascal over 62. So the safety factor is 4.677. So it means tak, ini kalau sigma 1, sigma 2 like that lah. So it means basically the tube actually, kalau I don't want to answer it like that, I want to use this value. You understand what I mean, class? That one, normally exam they are friendly. Kalau you miscalculate part 3, part 4, everything now. Okay, let's say kita calculate for this case. The one, not the given one. So what is our safety factor? Our worst case is compression, right, guys? Okay, class, we already calculate this one. Are you with me? My video, can you see my video or not? Okay, yang tadi kita punya case, compression is the worst case, right? Where we have sigma 2 is negative. Okay, in our case like this, in this orientation, we have kita punya sigma 1 is 0, sigma 2 is negative 45.123. Okay, want to try this one. Our case is like this orientation, they're showing based on that diagram of the question. So what is our sigma E? Sigma 1 square plus sigma 2 square so just put the value So you put the value sigma 1 0, okay, we have sigma 2 negative 45.123 square minus sigma 1 0, itu je lah, betul lah kan? Pasal sigma 2, sigma 1 is 0 kan? So we have sigma equivalent is 45.123 lah. Plus, betul tak? Same value. Same value. So safety factor SY over your sigma equivalent. So berapa? SY tadi 290 kan? SY tadi apa? 290 kan? Over 45.123. So berapa value dia? Yeah, safety factor is 6.40. So selamatlah. So it means that soalan ni kalau based on this orientation the safe. Okay? Okay. Part 4. Okay dah lah. Ini yang soalan cepu mas. 3 marks What is the most, selalu exam ni, what is the most critical orientation of the swivel arm to support the monitor to state your engineering judgment ni? Okay, the most critical dia dalam keadaan macam mana? Ini you tak payah do calculation, your judgment. You explain in terms of text, writing. Explain it. Just a short statement. This dia swing kan, ini swing. Ini dia swing on Z like this kan. Pivot sini. Okay, let's say this one tak boleh swing on X lah. Let's say the orientation. What is the most critical? Let's say this one remain horizontal lah. I mean this arm. Okay, ini also will swing on Z axis like this. Orientation yang paling worst apa? What is the worst orientation of this swivel arm? The worst case. Yeah. Yeah. Yes. Yes, you are right. Either this direction, I mean the arm extend like this and the monitor is like this. Betul tak kan kelas? Sorry, my drawing not right. Okay, betul tak? Ini swing the longest distance. Betul? So 2 to 0. As long as extend the longest arm, that the what you statement 2 is good enough. You got 3 points. Extend. So they produce even you don't have to combine MY and Z because they produce the highest moment, right? The highest distance, you are right. So you just answer like that. Okay, itu yang inilah so it mean point is the tube is safe lah. Kalau you as engineer you select the size is safe, you got safety factor pun 6.43 tadi kan. Selamat tapi yang the worst case tadi sebenarnya yang you calculate safety factor yang part 3 tu yang the longer distance tadi sebenarnya already cut. Tapi dia tak ni actually hidden story dia ini adalah the longer distance yang tadi. Still safe, we got 6 point something tadi kan. Tapi in our case yang itulah they already give to you. Alright. Kelas okay ke? Ada question apa ke? Right. Korang nanti ada assignment kena buat. Alright. Tapi janganlah last minute buat kerja, nanti tak ada juga Okay, tengok ni pula. Yang ni, can you see this one? Tak boleh. Ya. Ini exam question on 2018-2019. That's one. Okay, ini we have a shaft. Then we have a lever like this. Okay, actually the shaft ni connect to the lever dia, arm ni, DE, and also EF. Tetapi what we focus here is on the shaft, ABCD only, our shear diagram. So we don't go for extend ABCDE. So since kita just focus on shaft, when you do shear diagram on this, you have external moment. Be careful about it. This is about free diagram. Because in this case, are you watching this question? System pulling. In this case, kalau you buat shear diagram, okay, find the force at lever ni tak ada masalah. How do you find the force here? Summation of torque is 0. The hint. Yeah. Yes. Yeah. 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 This axis, right, on this, along the shaft here, kan? Yes. This F time ni and this F time distance 140 ni produce torque this direction, right? Yes, that direction. But the weight, this one 1000 kilogram times 9.81, this force times the radius of the pulley, 25, right? Produce the same torque. Clear, class? Are you understand or not? Summation of torque is 0. Okay, the force ini adalah 1000 times 9.81, this one kilogram, Newton. This one times the force here times 25 equal to force distance. So you got force here lah. Okay, tetapi bila you buat shear diagram, be careful. Shear diagram is only on your, okay, I show you in the video. Bila you buat this one, okay, kalau if you look on shear diagram on, dia draw shear diagram, moment and torque diagram of shaft ABC. Okay, dia cakap ABCD. Sorry guys, ni typo mistake ABCD. Ni, ABCD, bukan ABC, ABCD. The shaft only sampai ada di ABCD. Okay? Draw shear diagram. Okay, be careful shear diagram. Tengok kelas. Bila you buat shear diagram, I think shear diagram you don't have XY plane, you only have XZ plane. Pasal you can see, you punya force, everything is on Z. Nampak tak? This force is vertical. This force is vertical. Betul tak kelas? Yeah, shear diagram only on XZ plane. Your shear diagram only on XZ plane. So you punya, okay, be careful about this one. You have external moment here because we are separating the force there. Okay, this is our A. Be careful about this one. A, can you see my video? A, 150B here. And we have C 100 also 50 here. And we have and we have 120 here at D. Okay, 120 here at D. Okay, be careful. Because I'm removing the member DE and also this EF. We have a pin here again. We have a pin, small shaft here. I'm removing that. I transfer that one because this is A, B, C, D. I'm only focused on the free body diagram of the shaft. So what is, if we transfer that force to here, I have to transfer that force to here. Am I right? Boleh dengar sekarang? Okay. No, not supposed to be upward because if you look on the free body diagram, okay, kalau I make it. Okay, I would like to show you the free body diagram. If we make the free body diagram of the components separately, as you can see here, we have a small shaft here, and this is our point E, and the force is acting downward, and the force is 175.18 Newton downward, and the distance here is 120. Right, and we know this is our x-axis, this is our y-axis, and this is z-axis. If we look at this for the free body diagram from for this small shaft for the spin, so the counter react at E should be upward. And also, if we look this force time the distance, it will produce this moment turning like this. It will be on negative y, but if we take the reaction at point E, it should be counter react instead of clockwise, it go counterclockwise. Okay, it will go counterclockwise, and the direction is on negative y, right? Okay, and if we look at the member BE, where it is our member BE, DE, okay, this is our member DE. So DE will be joined here. So since the force here which is 175.18, and E is pointing upward, and E joined to E here, it will cancel out, so E will be, force will be downward, the same value here, 175.18, and at point D, it should be pointing upward to make it balance 0.18. And also, if we look, so at E just now we have, at E here just now we have moment Y at E. So this is moment Y at E here. But when E join here, so the reaction here have to be counter react. It should be this direction. If this one is counterclockwise, this one will go back to clockwise, where this is moment Y. Where moment Y is the same value here, where is the force time the distance 120. So if this one produce clockwise moment, so at DE in actually is not become bending, it become twisting, right? At here it become bending by the same value, but in here the MY is the same, but it's more like twisting the member DE. So at the end, at D here it should be counter react. Since this one is go for positive moment Y, at D it should be go for this one is clockwise, so this one should be counterclockwise MY, the same value. Right? Okay, another thing for member DE, since we have force here, okay, the force is downward 175.18, and the distance between here, the distance of this member DE is 140, so this force, the distance 175.18 times the distance 140, it will produce this kind of moment X. It will produce moment X of what you call it, positive X direction. So at D, so that's causing from, if you're looking on the right side, so this 175.18 times the distance 140, it will produce this moment X at D. But at D, if you look at the end of D, it should be counter. This one is go for clockwise, and at the end, this should be, it goes for clockwise direction. So this is moment X, where moment X is the 175.18 times the distance 140. Moment Y is just now moment Y is 175.18 times 120. That's moment, but this one is moment X. Okay, the moment X is where we have like couple, right? The force couple 175.18 times the distance 140, it produce this turning of moment X. But at the end, at D, it should be counter react, go for counterclockwise. Okay, the counterclockwise. So this is a free body diagram for DE. Alright, if we look at the shaft free body diagram, so this is your shaft. Okay, if you look at the shaft free body diagram, so this is your point D. So we have A here, then we have B here, this point C, and the D. The D here will be joined to this member DE. So this one, since this member DE, the force is upward, so for the shaft, it should cancel out to become 0, so it should be downward 175.18. Okay, at this moment Y, okay, moment Y at D, we have moment Y of this direction, but for the shaft, you have to cancel out, we go for this direction. So the moment Y at point D here on the shaft, it should be like this. Yeah, where your moment Y is 175 times 120. Okay, what about the MX? Okay, at D we have MX. Okay, MX, where your MX is force times the distance 140. All right. So for the shaft, if at point D here the MX is turning on positive X. Okay, but at Y it should be cancel out. It should be balance, counter react. It should go for this direction. How can I draw like this? Like this. It should go for this direction, mx, where your mx is going to negative x direction. Okay, so that would be your this mx. Actually, we can call it tau x, because if you look from the right side of the shaft, okay, we have the shaft at point D, and we have our member DE. Okay, our member DE is our member DE, and we have a small shaft here, and we have the force F here, 175.1. So this force is turning this force time the distance here, 140 here. It produces torque X, or in member D we call it moment X, but here we call it torque X. That's why our turning, I rather call it, we should call it not moment X, torque X, where torque X is the same as moment X. But in member D, the turning is on positive X, but in shaft it should be counter react, go for negative X, because this force time 150 causing the torque to the shaft. Okay, that's how if we separate each component and we make a free body diagram for each component, that's how it looks like. That's why, so for the shaft AB, we can see the force is downward, and we have a moment Y, and we have a torque X. So that's why in your when you draw shear diagram of ABCD, okay, of ABCD, okay, when you draw the shear diagram for when you look from this view, so that's why your shaft like this, your A, your B, where you have your pulley, your C is a bearing, and it's your D. So we have the force straight downward, 0.18, and we have moment Y, this direction, moment Y, where your moment Y is 175.18 times the distance 120. So we have like this. So that's why on the shaft we have moment Y, and the force is downward. But when we look on the side, we have torque X, and when we go for the side view, we have torque X go for negative X direction, torque X, where your torque X is this 175 times 140, 175.18 times 40, 175.18 times 140. That's the torque X. So that's why when you draw the torque diagram version X, so since we have torque at B, because B we have, remember we have but we have the pulley there. Okay, if you look on the question, hold on. Okay, if you look at the question, we have a pulley here, all right, pulley, and the pulley is causing on positive X. So at B we have positive. This is a value of our torque X. So since the force is 100 kilogram times 9.1 times the radius for this torque, okay, where is the torque is actually is 17.18 times 40, is the same value of this torque, causing is turning to this direction, and it must be counter reactive. So at B it goes for positive X, and it cancel out at point D. Yeah, here is point D. At point D it go to negative X. That's why our torque diagram is like this. Right, I hope you understand my explanation on this free body diagram of each component when we separate the shaft, the member E, and also the pin here. Yeah. So moment is F times distance. What is the distance? Distance of your pin 120. Betul tak? Okay, your F times 120 distance of T. So that's your external. You have external moment sini, guys. Okay, you have external moment. Okay. So your shear diagram is macam ni. You have the force F like that, you have external moment. In this case, you have external moment because kita separate shaft ABCD from member DE. Kalau if you look everything is there, you kena buat extend your, tak apalah, I make it ABCD because they ask you to draw the shear diagram of the shaft ABCD only. It's not talking about everything. Okay, so now you make, okay, you make a shear diagram. Since we have at B, okay, since this is Y, X, Z plane, we don't have XY because our force everything on Z. Z plane. So we have the value of here is everything we have. Yeah, class. Can you hear me? Boleh? BZ lah. BZ is 1000 times 9.81 Newton. So berapa? 9810 lah kan? 9810. So you have AY tapi kalau logically, if this downward reaction of AY is upward lah. Betul tak? Sorry, AY, AZ AZ is upward. AZ is unknown, you have to solve it, and also you have bearing here. Kalau this is downward, I think not sure. Either this is bigger because this is 9810 Newton. Kalau you put it downward, you can find negative value. Let's say kita assume dia ini upward also, pasal this is downward. Yeah, this suppose CZ is upward. So you solve for moment at A lah. Moment at A0. So value FD ni berapa? Dah ada dah. If you look on your ni, dah ada you punya solution. You to look on the solution. Kita dah pukul berapa ni? I want you to study the solution here. In your e-learning. Okay, if you look on your e-learning, can you see the e-learning tak? Test solution, test 1 ni. Ni, nampak tak ada diagram? Can you see the, cannot see diagram solution. Nampak? Share diagram, nampak? So you solve lah ni, tak payahlah saya write ni So you follow, tengok the solution. So that's how we do. Force tu kita buat summation of torque 0, you can get your force kan. Force in 175, you transfer, so you go for, direct, you transfer like that. This one is clockwise direction moment because you focus on member ABCD. So you make a shear diagram only on Z plane. We don't have because since we don't, the value, all the force is Z, the Z direction. So only exact only. So you make a shear. So moment at A, this one I think you know how to do it lah. Moment at A, so you got your, then from moment at A. Pasal ni I pakai software, apa nama dia, MathCAD. So actually the moment at A is 0, so you got 981, ni counterclockwise negative times 150. CZ assume upward, positive times 300 because moment at A. Then, okay, be careful. Then, kita ada external moment guys. Clear tak guys? So macam ni. So I show the equation is like that. Bila you do equation tu, moment at A tu, in my live video, moment at A tu, and also you look on the solution. The moment counter, I say counterclockwise 0. So we have BY, we assume downward kan? BY is downward. So BY 900 kali, tadi berat dia berapa? 100 kg kan? 981, bukan 9810, saya silap tadi ni. 981 lah. Apa 1000? Berat dia 100 kg so not 100 Betul kan? 100 kg Okay, berat is 100 kg. So 981 So 981. So moment at A0 tu 981 Newton weight of the weight tu kali 150. Pasal dia produce negative kali 150. Dan kemudian the CZ, nampak CZ is pointing clockwise pointing up. So clockwise direction moment at A. So plus CZ kali 300, 150 and 150, 300. Okay, ni be careful. You have, can you see at D? D tu downward kan? Downward, so counterclockwise. So it's negative 175.18 times total length is 300 plus 150 plus 420 lah. Okay, 300 plus 120. Plus that, nampak tak? Class, are you listening or not? Ada external moment, nampak tak? Class, we have external moment. Nampak tak kan?
Yes, Doctor.
Class, this one. Yes, we have external moment. Kita transfer from the lever to, from the handle to here, kan? We have moment clockwise. So, that moment clockwise or counterclockwise? The turning of that moment. Clockwise kan? Hello?
Should be negative, right, doctor?
Yeah, negative to that moment tu pasal tadi kita got the force is 175. So kali distance 175 ni lah. 17. Jadi we got moment tu 120 already calculate lah. 175 times the distance of your pin tadi. Pin yang distance pin tadi. So you got 121 to 21 or to 1.6. Okay, line putus. Okay, boleh nampak So you have to. So you got your CZ. Be careful. You have negative force tadi at D and external moment. So you got your CZ value from there lah. CZ memang upward, memang positif CZ you got 8 or 5 positive. 8 to 1 Newton. Okay, dan kemudian you transfer itulah equation yang that one tu. Fz, since this is Z, Fz equal to 0, upward is Z. So you got your minus AZ minus 981 plus CZ upward positive plus 805.81. This was N plus the force yang tadi at D tu. Force you transfer di minus 175.18 Newton equal to. So you got your exact value. Your exact is 350.357 Newton. Okay. Guys, are you watching the solution? Okay. Then you make the shear diagram. Nampak guys? Class. Okay, the AZ memang upward memang betul. Is ni. Kalau you got negative, if value of your AZ or CZ negative, you mean you reverse the direction is positive. Class, are you listening? Class, line putus ke? Dengar kan? Okay, so that's why you punya AZ tadi is 350 memang naik positif. BZ minus 981 mana? So you got balance 96 negative 630. Then CZ tadi kita get 805 naik balance 175. Nah, dia must balance, mesti balance like your account, mesti balance. Tak ada no such thing shear diagram tak balance, mesti balance. Okay, 175 downward, so you go back to 0. Okay, be careful about moment. Ni moment ni be careful. Okay, you know moment ada area under shear diagram. Okay, moment tu tolak M1 0. Okay, M1 is 0, starting 0. M2 is area moment. 350 ni sekali the distance 150, you get okay, right? Okay, but now, okay, you punya area is negative. Be careful. Some of you student ni dia miscalculate your first assignment tu. Negative, this negative. Moment 3 tolak moment 2. Moment 2 is 52554. It means moment 3 that you want to search tolak 52554 equal to negative area. Negative because the area is negative. So you get your moment 2 is negative 42. Okay, apply. Ni be careful. Because we have external moment. Tengok Bila you go here, memang you tak dapat zero moment. Because why? Kita cancel out by external moment. Clear tak kelas? Kelas, are you with me?
Yes, doctor.
Yeah. Moment 4 tolak moment 3. Okay, moment 4 ni you dapat. Moment 4 ni unknown. Moment 3 is negative. Jadi moment 4 minus 420 nampak. For moment 4 minus pasal this value negative because difference of moment is the same is area. Moment 4 is unknown minus 42042 equal to area. Area is positive. 175.84 times 130 easily. That you cannot get zero. You got 21 up here. 21 O to 1 positive moment. Does it balance? Nampak tak kita calculate moment external also 21 O to 1? Nampak tak? Dia cancel out kasi. That's why dia jump sini. Dia jump sini. Nampak tak? Because since kita at D we have external moment, dia jump. So ini cancel out. So the moment, understand tak lah? The moment that you calculate from your moment diagram must equal to the external moment ni. Mesti equal. Then you balance. Ini mean dia jump straight away down. Because external moment, the moment diagram is like this. Are you listening class? So macam tu. Kenapa okay, so why the gum go to negative direction? Because kenapa? This one, kalau clockwise, dia go for positive X ke negatif? You go for, you might get confused. You go to negative. So negative dia go downward. Pasal kita dapat ni positif, go to negative. Pasal di external moment, dia cancel out, dia go to negative. So this is your moment diagram. Okay, and also you have torque diagram. If you look on the question, torque diagram, since this B ini produce, okay, this is X axis, ini right after B, dia produce torque X positif. Okay, so that's why you punya solution, ni positif, right after B positif. Sampai if you look on the question again, sampai dekat D, up until D, dia produce negative X direction kan, dia produce yang ni looking from the right, it turn clockwise. So dia reverse X direction pasal macam ni. Dia produce reverse X, go for negative X. So that's why you punya moment diagram tu, yang ni dia terus jatuh bawah lah. So sampai sini. Mula positif, this moment diagram. Okay, that is answering dia punya question 1. Find the shear diagram. Find the diameter of shaft ABCD based on dissociation energy theory DET. Okay, it means, tengok sini kelas, kita sikit lagi sebelum kita quick. Boleh kelas Boleh, kelas. So, it means that, okay, sekarang ni, you dah buat shear diagram tu, the shear diagram is already calculated. Okay, you know, kalau you look at here, which one is critical? Kita only have XY plane, XZ plane saja. Kita don't have XY. You don't have to buat XY plane square plus moment XZ plane. You only have sekarang shear diagram kita, we only have XZ on shear diagram. Okay, pasal kita, the question ask you, find the diameter of shaft ABCD. You mean shaft ABCD based on, you mean you find the shaft, you mesti based on critical condition lah. Okay, along the shaft ABCD, which one is the critical point? B or C? Yeah, since B have the greatest moment value. But do not ignore negative value. Sometimes the negative value, even is on negative side, is bigger magnitude than the positive. Be careful about that. Just to take you have to be aware of that. Okay, tapi in this case yang inilah 52 ni is greater. So B is critical. So the question asks you, since your moment, you don't have to moment exact square y square root. No, pasal you only one plane. So your moment, total moment at B is 52,554. So if you look on my live video ni, class, look at my video. So dia cakap find since the question as already given, the safety factor of the shaft is 2. Nampak tak? And the material EAISI 1045 hot roll. Okay? If you look on my live video. So you punya moment at B is critical is, okay, before that we have torsion, be careful, do not, we have 52.554. Okay, so element at B, we have moment. Let's say consider upper tak apa, we ignore, we just consider tension because upper portion material there, because upper is tension, bawah is compression, never mind. Okay, let's say kita consider tension, sigma X lah, sigma X bending lah, sigma X tu is bending because moment this element at B. Kita consider ni, sigma X we have berapa? Moment, bending moment. What is bending moment? We don't have any axial, right? Ini only moment. Bending moment is what? 32 for solid shaft, 32 moment at B over pi d cube. Are you watching my live video class? 32. This is only solid shaft, equation in bending moment. Time moment at B is 52.55. Ini Newton millimeter over. Okay, only variable is pi d cube. Our thing is unknown in variable cube. So in term of D. Okay, in term of D. So it means 52.554 times 32. Okay, pi. Okay, sorry. 52.554 times 32 divide calculator saya tak ada pi. Kau kira kan untuk saya pi berapa? Bagi pi? Tak. What's the answer here? Over d cube. Per d cube. Your variable only on d cube. What's the atas value? This one, everything divided by pi. So lima tiga point 10. Okay. 535310.6. Okay, this is your bending stress in terms of variable diameter. Alright? Okay, since also we have torsional stress, right? At B we have torsional stress like this. Torsional, right? Torsional stress. Pasal B kalau ikut question dia go for after B they go for positive X. They go for positive X. It mean to the left, to the right of B they go downward. They go upward. Sorry, supposed to be like this. My mistake. B upward. Ini upward, to the left, downward. To the left, downward. Okay, this upward, so this one balance macam ni, this one balance. So this one consider tau SY lah. Tau Z pun boleh, tau SY pun boleh. Sigma X, tau SY. Alright, so tau SY is, what is tau SY? torsional stress is 16 T over pi d cube. So what is the value of our torque just now? Force time 140 kan? What's the value of torque? Value of torque berapa? You punya distance 100 kg kali 9.1 times 25 also the same, or force this one, tadi force ni berapa? Force tadi berapa value tu? Berapa? What's the value of torque? Times 140. That's the value of your torque. Berapa? Value of torque. Torque X is 24. Ni. What is torque? Torque yang tadi lah, you punya force tadi, time distance lah. Force tadi berapa? Your force tadi berapa value dia? Boleh dengar? Okay, the torque value tu yang you punya force is 175 times the distance here is member DE distance is 140. Ataupun the weight 100 kg times 9.81, you mean 981 Newton times the diameter of the pulley 25 is the same. So that will be your torque value lah. Torque value. So torque value is apa tadi? 175.18 times 140. So torque is okay 16 times 2452.5 torque value over pi d cube. So apa boleh kirakan untuk saya this one? Per diameter. Berapa? Apa tadi? Sorry. Apa dia? Jam? Apa? 124. 182 over d to the power of 3. Okay, that is your thought. So everything in variable diameter 3. Okay, now look so okay, sekarang ni dia cakap the material is okay, the safety factor. Okay, find the safety factor. Okay, the part 4. Find the diameter of the shaft based on dissociative energy theory. Okay. So since this the safety factor already given, the question is 2. Okay, 2. Safety factor is 2. We know that DET, based on DET, safety factor is 2 equal to your SY over your sigma E. Betul tak kan? Plus. Then also the material is already given. 1 AI, SI, 10, 45 hot roll. So we can get the SY. What is SY value? Okay, look on the textbook. Boleh nampak the textbook Boleh nampak my textbook? Textbook. 1045 hot roll. Berapa value dia? Ni. 414 megapascal. SY. 414 megapascal. So that's why, since safety factor is 2 equal to SY is 414 over your sigma E. So what is your sigma E? Sigma is, kalau you ada biaxial stress, in our case, we only have biaxial kan, saya cakap, kalau biaxial, we have tau SY and tau SY. Sigma is shortcut dia is like this, sigma X square plus 3 tau SY square. Betul kelas? Are you with me? Yeah. Then you get your diameter. So everything is in sigma X. Tadi kita sigma X tu sigma bending lah sigma bending kita 535310.65 over d cube square of it plus 3 tau XY ni 124,905.82 over d cube, this one square. Faham? This your sigma E. Kalau you still in variable diameter lah. So okay, nanti bila pasal this one you square you go back, you punya sigma E ni dalam bentuk over per d3 lah. So sigma E you get is 5, ini saya 0.7, ini saya kali, ini dah ada solution, look on the solution, times 10 to the power of 5 kelas over d cube. Plus, are you listening? Okay, safety factor is 2. Equal to SY is 414. Betul kan? SY 414, yeah. 414 megapascal over sigma E is 5.7 E times 2 to the power of 5 over D cube. Since safety factor is 2. So we get our D lah. Diameter is 14.076 millimeter. So we need safety factor 2. We need, so we design the shaft diameter must be 14 on, not less than 14.076. Okay? You go for 15 lah to play safe lah. Go for 15. Pasal 2 pun still not okay lah. Tapi ni, go for 15. Take the rough value. Pasal shaft ni pun, take the rough value 15 selamat lah. More than, it means safety factor you more than 2 point something. Clear tak kelas? That's how you do it. Kelas boleh Alright? Kelas? Boleh Understand
Yes, doctor.
Yes.
The last one ni golden question lah. Biasa normally like that lah. Okay. How will the diameter of the pulley? Ni. This is a pulley. Can you see the question kan? Pulley. Kalau pulley ni, ini kalau increase diameter pulley or reduce, apa the effect the shaft punya strength? How will affect the diameter of the shaft? Sorry. How will the diameter of the pulley affect the diameter? Tadi kita find safety factor, we find out the diameter of shaft supposed to be 14 kan? 14 point something. Then safety factor 2. And based on SY value method that we select. Okay, how the pulley diameter ni affect diameter of the shaft? Can you make a statement on that? How do you explain it? Short statement. In diameter ni, kalau we increase diameter pulley, how does it affect the diameter? Let's say you increase the diameter of this pulley, how does it affect diameter of the shaft? Yes, you are right. Yes, more top. Yes. Yeah. Okay, you are right. Okay, you just write statement, put the right statement, just write it there, then okay lah, full point. Okay, understand? Alright, that's how you do it. Okay, okay, ada ni soalan buat bagi ni, nanti saya letak dalam WhatsApp ni. Kelas, ini assignment. Kelas. Boleh nampak ni? Tak nampak? This one nampak? Tak nampak? You kena buat 2 question sebenarnya. Sorry, tak boleh satu question tak boleh. You buat question 1, question 3. Ini. Exercise 1 ni here. Ni. Diagram ni nampak kan? 1 and 3 buat. Okay, deadline tu ya bagi lebih-lebih sikit lah, tapi janganlah last minute buat Okay, go for attendance Tak ada question apa Ini session 8 kan? Ya, lebih kurang Tak. No, do not worry. The for test 2 is easier than test 1. The test 1 ni yang like solid lah, pasal your fundamental knowledge tu we have to test you to be ni. I mean the test 2 is much easier, pasal you more on direct application, procedure of select gears, procedure of select bearing, procedure of select bear, just a procedure. Engineering work, you follow the procedure saja. Much easier. Yeah, first one, the first part ni yang fundamental to test you free body diagram. Nanti later on you punya question 2 on your test 1 will be fatigue. Fatigue tu little bit you have to know lah. Little bit fatigue analysis, you punya strength is no longer SY, endurance limit SN. Endurance, but just now safety factor is SY over your sigma E. But fatigue, you not use SY, you use SN. SN is, I mean, your strength is lower than your SN because loading you variable, loading you fluctuating. I mean, you no longer use yield strength. Your strength of your material is lower because of the loading is frequent, they are variable. So you use endurance limit. SN is LCG. Nanti I explain to you other factor you have to multiply to your, then last kali baru your SUT. Ada reason, not S1. Okay, scan your attendance. Okay, Assalamualaikum warahmatullahi
Thank you, doctor.
Welcome.